Hi, everybody. Welcome to the Data Show. I'm your host, Chris Greco. For the next 30 minutes, we'll be talking about different types of data, how to collect, how to analyze, all the other things that have to go along with that. Today, what I would like to focus on are an area that was brought up by a viewer who contacted us through CANDR at statisticsleuth.com and asked the question, what is the difference between mean absolute deviation, and median absolute deviation? So this show is going to be dedicated to answering that question. We try to answer any questions that are given to us through the email that I give in the show. So if you have a question about data analytics or about different techniques or about things that maybe confuse you because maybe you've seen it in a research study and you're not sure exactly what that means, please ask us the question and we will dedicate a 30-minute show to that technique so that you do not become confused about the techniques that are used within the data analytical aspect. Very important. So today, mean absolute deviation and median absolute deviation. Sorry about the misspelling here. It's supposed to be mean, MEAN, absolute deviation. So that's what we're going to talk about today. So this is the first question that we've had of the series. I really, really appreciate the individual who did that. They asked for anonymity. I'm giving it to them. They asked the question, and I really, really appreciate that. And they asked it through the email that we present every single time on this show. So please, please, please do not in any way, shape, or form think, this is a stupid question. It is not a stupid question. It is, no questions are stupid. None, really, seriously. If you want to know what an average is, be more than happy to go over that in a show. So that's the difference. So what is the difference between the mean absolute deviation, and median absolute deviation? So we're going to describe the difference between each and how one may be more accurate than the other. And again, thank you very much for the question. Really appreciate that. And we'll try to answer the question within the same day or two. But the thing is, the show may not come out till that next week. So if you can wait that long, fine. If not, we'll go ahead and email you back with the explanation, and then we'll present it again on the show. So again, and thanks for viewing the video. Appreciate that very much too. So let's start with a very simple aspect of what is the mean, right? What is a mean? So the mean is basically the average of the data that is presented. It is basically the sum of the numbers or objects, whatever you want to call it, divided by the number, the count of the values or objects in the data. So if the data is 13678 or 13687, then the mean of those would be the total number added up, which would be 25, divided by the count of that would be 5, which then 25 divided by 5 would be the average. Now, it's just simple data. Very rarely you're going to see a data with just 5 numbers in it, but that's basically what you have. You've probably done this somewhere in your academic experience when you're talking about GPA. GPA is very similar to this, is that you take the number of the grades that you have, you divide them by the count of the courses, and you got yourself a GPA, grade point average, right? The A average, mean average. So the result of this data set is 25 divided by 5, or 5, which would mean the average of that. Now, although this is very straightforward and it's used all the time, the bottom line is that the mean is not robust. Basically, it can be skewed by high or low values within that data set. And this is a very, very, very important aspect of what average is not beneficial, right? It's not the best it's not the best way of calculating the center of a data. But yet we do it. We teach it, elementary school, and we teach it very well. But basically what happens is that that's not the cool thing, because it's not very robust. Now, what is the mean absolute deviation? Well, the mean absolute deviation is taking the average and then taking each value minus that average, but taking the absolute value of that. Now, a lot of people get confused with absolute value, so let me explain it this way. If I were to take a step forward, right? I take a step forward, that's considered to be a positive step. If I were to take a step backward, A lot of people think, well, that's a negative step. Right, it's a negative step from that area. So basically, you're taking a negative step backwards. But let's say I'm taking a step forward and I'm taking a step sideways. Is that a negative? Is that a negative step? No, it's lateral, right? So you sit back and you say, okay, well, I'm taking a lateral step. Well, is that considered to be a forward step? No. Backward step? No. It's kind of a lateral step, but it's still a step. You're taking two steps. So what happens is that you say, well, it's not positive or negative. And basically, absolute value is about the same way. Whenever you take a step forward, you're really taking a step forward. And it's interesting how a lot of people sit there and say, oh, step backward. But literally what you're doing is you're still taking two steps. So whether you're taking them forward or backward, they count as positive steps. They count as basically steps that you're taking. In other words, if you take, say, I'm taking 3 steps, and you take one step back, one step forward, and two steps backwards, you're still taking 3 steps. Absolute value basically doesn't count the negative in that area. And that's where absolute value comes into play. And a lot of people get confused about that. So basically what happens is when you have the same data set as you have before, in this example, 13687 with a mean of 5, but this time what you're going to do is you're going to take the absolute value of the difference between each value and the mean. So now you have 1 minus 5, which would normally be negative 4, but that's not what it turns out to be. It turns out to be 4. And 3 minus 5, which would be negative 2, but absolute value means you get rid of the negative, so now you're at 2. So basically what happens is this turns out to be 42132, those differences. Then you take these values, you divide them by the count of the values like you would a normal average, and that would be 12 divided by 5, which would give you a mean absolute deviation of 2.4. So now what do? So that's kind of interesting when we talk about that. So the mean absolute deviation is a better measure of variability because it is easier to calculate than a standard deviation. However, and this is really the same as standard deviation, the MAD is based on the mean. So the mean, I've already said, is not robust. The mean can be skewed by high or low values. Same with the mean absolute deviation because it's based on the mean. So you sit back and you say, well, is there a non-robust measure that we talk about? You know, is there something that's not skewed by high or low values that we could use to try to gain a good solid center of that data, right? So that's what we're talking about next. And we talk about now comes the median and what they call the median absolute deviation, or another MAD. Sometimes they use MAD for both of those. But what I do is I use MEAD, which is the median absolute deviation. So the median is a robust measure. And here's why, is because you're measuring the physical center of the data, not the arithmetic center of the data, numerical, whatever you call it, but it's both of them are numerical. But basically what you have is you have the physical center of that data. So same data set as before, 13687, but what we're going to do is we're going to sort these numbers in numerical order, 13678. You find the center number, and that's the median. So in this case, it's 6, halfway between 1, 3, and 7, and 8. Now, the median, so basically it's 6 is the median. Now, remember, if you look back, the median at that point, the mean was 5. Well, the median's 6. Well, the median is not influenced by the higher lows. It's not skewed. It's basically the physical center. Now, you don't believe me, right? Oh, Chris, that's hard for me to believe. Well, change the 8 to 8,000. If you change the 8 to 8,000, the median is still 6. The mean is not going to be 5. Guaranteed the median is not going to be 5. Not with one number is 8,000. It's going to pull that number way up. But the median stays the same. So now we take the median and we use it for another measure called the median absolute deviation. So you find the median, right? You first find the median, as we did. We know it's 6. You subtract each value from the original data set from the median, again, using the absolute value. So now you have the result is, interestingly enough, 53012. You take those numbers, you put them in numerical order, 0, 1, 2, 3, 5. The median absolute deviation turns out to be 2. What this means is you can use that median absolute deviation in place of a standard deviation if you want. You can actually make a normal curve and decrease bias and skew in the data by using the median absolute deviation. I actually did a paper on it for the Department of Defense using it for geospatial aspects, and it was accepted by the intelligence agency of the Department of Defense, and it was used for that purpose. So that's what we're talking about. We talk about that median absolute deviation. However, it's best to use, this is interesting now, even though I said, based it on the normal, you use it for non-normal data. So if you have non-normal data, which is, there is, by the way, folks, there is no such thing as abnormal data. You'll have normal data and abnormal data. No, it doesn't work that way. It goes normal and non-normal. Well, it's normal. Normal data is basically where the mean, median, and the mode are almost the same, and they basically are the top of the curve. The curve goes up and over, and that tip of the curve basically is the mean, median, and mode. That's when you get into normal aspects. Well, best to use that for non-normal. According to the National Institute of Standard and Technology, I put the reference up. You can take a look at it. It goes through it and tells you all the different aspects and all these things. The mean is very well described here, statisticshowto.com. Very, very good reference if you want to get a description of what each of these things are, and you don't want to listen to Chris Greco. That's cool. Go to that site. Very good site. I really use it a lot. It's a great site to use. NIST.gov, also great site, and a very, very good site from the standpoint of it basically has a handbook, a statistical handbook that goes through all these different statistics and statistical methods at a very high level. So you have to kind of understand a little bit about statistics to make it work, but it is a very, very good reference. So I highly recommend that. So which is right for my data set? So the mean is the basic, it's a very, very basic part of the descriptive statistical formulas that you use. And you preliminarily analyze data using mean, median, mode, standard deviation, variance, all these things, right? However, it's not a mean. It's not a robust measure. And the very interesting, ironic fact is that the mean is used in almost every other set of measures. So basically, what you're doing is you're taking each of the measures and you're putting it in a situation where each of them are going to be skewed. So that could be a very, very big problem. So the mean absolute deviation and median, by the way, median is also part of this descriptive part of statistics, right? But it's less affected by high lows. The mean absolute deviation uses the non-robust form of measure, while the median absolute deviation uses a more robust form of measure. Remember, robust, right? It's not affected by the highs and lows. Non-robust, it is affected by the highs and lows. If the data is normal, then the MAD or even the standard deviation will work fine. If it's non-normal, move towards the median absolute deviation as I've described here and use that instead of the standard deviation. And you'll see that you'll get probably better results. So let's do an Excel demonstration to show you how each of these things work, as well as showing you some of the formulas and everything else to go along with that, so you can set up your Excel worksheet to take care of your data. And I think we'll go through that, and that will help you to figure all that out. So let's start first of all with the mean. So this is the mean here, right? 2. So we take a look at this. Now, what is the mean, right? I'm sorry, this is the mean absolute deviation. Sorry about that. So what we have is we have, here we go. This is the mean. Okay. So this is interesting because, let me do it this way. We'll actually, sorry about that. Let's go back. Okay. This is the mean here. Now, basically what we're going to do is the mean is going to be an average. So you could either do average, you could do average, and you could take each of these and you get your average of 5. Okay? Easy enough, right? Or, interestingly enough, they started doing the actual mean, which is very interesting. Same thing. So what you do is you have these average or mean, and that works out fine, and it's a good way of doing that. This is the mean absolute deviation, which is now we're going to do the mean absolute deviation, and we're going to take these 5 and you get 2. So basically, and just to make sure you don't get confused, this is the mean and this is the mean absolute deviation. So you don't get confused on that. So basically this is the mad, this is the mean. Now, let's talk about median for a second. So median here is the same thing. A1 to A5 equals A1 to A5. So let's see if I can do this. Nope, don't want that. I think if I do it this way, I can actually, yeah. So this gives you, in fact, let's get rid of this. This gives you all the different aspects of the mean. The mean, this is how to go through each of these areas. And in fact, let's get this a little bit smaller for you. Bring that over. Come on, up, over. So this is how to do each of these areas. There's your median. So we're going to do an equal median of that. And now what we're going to do is we're going to go through the process of doing the absolute value. So the absolute value is going to be A1 here minus C4. Now C4, what I did was I used it right here. This is the median. So by putting those dollar signs next to the C and the 4, I've made it basically an absolute reference, which means it'll never change. It'll always be C4. If you don't, it's called a relative reference, which means this will be C4, this will be C5, C6, and it won't work out well. So these are the formulas to be able to do the median absolute deviation. And then at the end, you take the median of these here, and that gives you the median absolute deviation. So, I mean, it's relatively straightforward, but it's nice to be able to have the formulas because you don't have to sit there and try to figure this thing out by hand or with a calculator or whatever else. Excel is good about that. It has the ability to have you go through these things and make it work for you. So that's what happens there. So let's see what the results are. Well, the median here is 6 because it's 13678. And you notice this is now what I want to do is I'm going to show you what happens. Remember I said I changed that 8 to 8,000. Let's say I did that. Look what happens in the mean. Look what happens in the mean, right? The mean all of a sudden is 1,600. The mean absolute deviation changed from what? 2 to 3, right? Median hasn't changed at all. Hadn't changed at all. So the median absolute deviation, interestingly enough, is 3. So the mean absolute deviation, the median absolute deviation are about the same from this area. So I just thought I throw that out at you to show you how that works. You know, that the median doesn't change at all. That median absolute deviation changes very little. So I mean, that's what you gotta take into consideration. So what does the mean absolute deviation do? Well, the mean absolute deviation allows you to take that non-robust and make it a little bit more robust, because it takes into consideration the absolute value of those differences as it goes along. But I just think that is interesting when the mean is so whacked, from that standpoint. And yet yet it changes that mean absolute deviation very little. Median absolute deviation very little. So that's the interesting part about the entire aspect of this whole thing. Now, the minute that you start putting another number in there, let's say you put in 9. The minute you put in 9, what that does is that changes the median. The median will no longer be 6. The median will now be somewhere between 6 and 7. Usually they take the average of those two, 6.5. But let's say we did that. Let's say we put in the 9. Well, what happens if we change some of these? So instead of one, we're going to do this. We're going to change it to that. See what it did? Didn't do much. Not to the mean absolute deviation. What about the mean itself? Let's see what it does with that. Well, it changes that up. What about the median? Does it do anything to the median? Yes, it does. It changes the median and it changes the median absolute deviation. It changes the median absolute deviation from what to what? Well, from 2 to 1.5. What did it change the mean? The mean absolute deviation, what did it change? It changed the mean absolute deviation from 2, and it changed it, but you'd think it would change it, but didn't change it. It changed it, it didn't change it. It literally left it the same as 2. So even though I harangued everybody about using the mean as this non-robust measure and then using it again in another measure, the bottom line is this mean absolute deviation helps to correct somewhat that non-robust nature. Just understand that the mean is still non-robust. The mean absolute deviation buffers it a little bit so that you have a little bit of a better measure. But still, you're basing it on something that is highly influenced by upper and lower values. But again, if I change that 9 to 9,000, it changes that mean absolute deviation very little, 2.5. So this is what I wanted to talk with you about today, is the idea that we have, a mean, which is the basic measure that we all use in statistics. And we're taking that and we're trying to make it so that we correct for some of that inability to correct itself whenever they have those high and low values. And that mean absolute deviation is a way of doing that. The median absolute deviation takes a non-robust measure and keeps it non-robust. I've always liked the median absolute deviation because it really does help whenever you have a wide variety of these values. And interestingly enough, even with NIST, they are very careful to tell you to use it with non-normal aspects. And the reason is because of those high-low values all over the place. If you try to take those high-low values and turn them into normal, that's when you come up with these issues and problems having to do with all the different research studies and everything else that are being done. So again, thank you so much. I really appreciate the question. I hoped I answered the question. I gave you some different references to help you with that. So I'm really hoping that helped you with what's going on. And always ask us the question. There's absolutely no problem with that. We love doing the show, and we would love doing the show with the audience participation. If you have a question and you want it to be answered, we'll certainly do the research and we'll answer it to the best of our ability. If there is something else you want to see or something else you want to know, we'll put the references in there, and you certainly can do some of the research yourself or go out and figure out exactly what it is that you want and go from there. So for the data show, I'm Chris Greco. Thank you so much. I really appreciate very much the question, and I appreciate your attention. And remember, always check the data, check the data, check the data.